This video is a walkthrough of this calculation here. I'm sure a lot of you looked at this and said, oh my gosh, no, it's not happening. I can't do this. I'm here to let you know you can do this. I'm going to show you how to do this. It's not too bad. Okay. I just wanted to say hi so you could see me, but now I'm going to hide. All right, let's get started. First of all, let's just talk about what each of these variables even means. Like what is all this? What's happening? Oh, hello. There we go. Okay, so this first one, f sub 1, that's a subscript, so we say sub. F sub 1 is going to be equal to the force that Earth feels from the sun. We're just going to assume that our two objects in question are Earth and the sun, because that's the problem that I gave you on your virtual lab. This could be any two objects, though. There's a force of gravity between every mass ever. Okay. F sub 2 is the force that the sun feels from Earth. Pretty similar. One is from Earth's perspective, one is from the sun's perspective. What this tells us is that force is going to be the same. Due to Newton's third law, we know that all forces have an equal and opposite reaction. That's some physics. Maybe you've heard that before, maybe not. That's okay if you haven't. This next one, G is our gravitational constant. This number will always stay the same. That's why it's called a constant. Some old man did the math for us, thankfully. And we know we just need to multiply everything by this number for this calculation to work. Our next one, m sub 1, that's just mass of object 1. In this case, we'll call it Earth. You could call it the sun as well, just be consistent. It really doesn't matter since we're multiplying. It's like 2 times 3 equals 6, and 3 times 2 equals 6. It's the same. M sub 2 is mass of object 2, in this case, the sun. And r equals the distance between the two objects, in this case, the Earth and the sun. What is our distance? Because they're so big, we're actually going to be measuring that distance between their core, not their surface. Just side note. We're actually going to square that number, and if you're not sure what that means, I will talk about it in a moment. So let's run through this problem. Let's say, since this is an example, let's look at Venus instead of Earth. What force of gravity does Venus feel from the sun? So we're just looking for one of these forces. That's what we're solving for, so I have question marks. From Venus on the sun, or from the sun on Venus, they're going to be equal to each other. Again, our gravitational constant remains the same. It's the same number. We just need to go look up what is the mass of Venus, what is the mass of the sun, and we'll have to look up what are the distance between the two objects. I already have the numbers plugged in, but just know I literally just Googled this information, found it, and I was like, I hope this is correct. Let's say that it is. Anyways, let's just start with this calculation. We know we're solving for F, so let's just start with F equals. And we're going to multiply these two numbers by G, whatever they may be. And this is our gravitational constant, G. You'll notice it's the same. It just stays the same. Let's see, mass of Venus, when I looked it up, came out to be 4.867 times 10 to the 24th kilograms. And you might be wondering, okay, what is this times 10 to the 4th business? If you're unfamiliar with that, this is scientific notation. Because really, let's see, I'll get a sticky note. Pretend you didn't see any of that. Really, this number is equal to 4.867. So I just moved the decimal 3 times. And then there should be 21 zeros following this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. This is this number. This is very obnoxious. We don't like to show this, so we put it in scientific notation just so it's easier to deal with. If you need more help with that, just let me know. Okay, so that's our mass of Venus. We're going to multiply by M2, which is the mass of the sun. When I looked it up, it came out to be 1.989 times 10 to the 30th kilograms. Then we're going to divide by the distance between the two objects squared. So I looked it up. This is the distance between Venus and the sun, 1.0809 times 10 to the 11th meters. Squared just means we're going to multiply this number by itself. So this is the same thing as squared, or you can plug this into the calculator and just hit the squared button. Either way, it's the same deal. Now let's go about solving this. This is kind of a monster. If you're unfamiliar with scientific notation, you're probably like, Miss Acuna, what in the world? Maybe you didn't say what in the world. Maybe you said something more vulgar. I don't know. I'm going to show you how to do this, though. I personally like to start with the top and work my way down when working these calculations. So I just copy and pasted this. Left to the bottom, the same. We're going to deal with that later. First, I want to multiply these numbers, okay? If you don't have a scientific calculator in person, fear not, we have the internet. And you can just Google online scientific calculator and boom, you get this. So we're just going to take these numbers. I'll show you one time how to enter them. Pretend you don't see this again or this. There's so much happening here. I'm going to take 6.673 times 10 to the negative 11. This is how you would enter it, 6.673. Instead of putting times 10 to the whatever power, we have this nice exponent button. And this basically means times 10 to whatever power. In this case, negative 11. I'm going to be multiplying that by, 4.867 times 10 to the 24. So 867 exponent, or times 10 to the 24th. And we have one more, times 1.989 times 10 to the 30th. 1.989 times 10 to the 30th power. Equal sign, boom, and it tells me 6.459773 times 10 to the positive 44th power. That's a big number, but that's basically how you use your scientific calculator. If that was confusing, you can just rewind and watch all that again. But this is the answer we got. You'll notice our units changed. I don't want you to worry about it too much, but I'm going to explain it anyways. We have kilograms to the negative second power, and we have kilograms times kilograms, which should be kilograms squared. So kilograms to the positive 2 power times kilograms to the negative 2 power will make them cancel out. We're just left with newtons and meters squared. Again, if that was confusing, no worries. At this point, I think I'm ready to tackle the bottom of this fraction. So I'm just going to copy our bar here. We have this number. We're going to leave it alone for now. And now we're just going to multiply these two in the same exact way that I just showed you. We end up with 1.168344 times 10 to the 22nd power meters squared. And last but not least, we'll just go ahead and divide. Same deal with the scientific calculator. You'll notice before we had meters times meters. Now I have meters squared. I have meters squared on top and on the bottom. They'll cancel. I'll be left with newtons, which is perfect because that's our unit for force. Once I divide them, this is what I'm left with. 5.529 times 10 to the 22nd newtons. This is the force that Venus feels from the sun, that gravitational force. That's our final answer. If we suddenly increased the mass of Venus by 2, or in other words, we doubled it, just like that question I gave you in the virtual lab, we would go through these same exact steps, but this time we would multiply this mass here by 2 to double it, and you would get a different number. I am not going to ask you to perform these calculations on a test. I want to make that clear. What I do want you to be able to do is say, if we increase the mass of one of our objects, how does that change the force of gravity? You can expect it to increase, right? Why I'm having you do the math, though, is I want you to show me mathematically, does it actually increase Show me the math, show me the numbers. Because this is science, math and science are married. They're very happy together. That's basically everything. If you have questions, you can ask, but I hope that this was helpful. I will see you guys next time.